Problem 3. Problem 3 is a review from Unit 2, dilations. Remember all of those rigid transformations and dilations? Here's a review. Find a sequence of rotations, reflections, translations, and dilations showing that one figure is similar to the other. So, what sequence of transformations would we use to show that one figure is similar to the other? Basically, we have to transform the big shape into the small shape or vice versa. Okay, we're using a circular grid. Take a look at this. I'm going to just look at some corresponding points. Looks like D and D prime are corresponding points, as well as C, C prime and C, B and B prime, E and E prime. Okay, well, D prime is 1 unit away from the center, and I'm just going to take a guess that the center point A is the origin or the center of dilation. How many points away is D? Let's count. 1 unit, 2 units, 3 units. Okay, so it looks like there was a dilation with a scale factor of 3. It looks like this little figure was dilated with a scale factor of 3 to be the size of this larger. So why don't we reduce the larger figure back down to its smaller size? Reduce it with a scale factor of 1/3. So now it is 3 units from the origin. If I reduce this using a scale factor of 1/3, then all the distances from the origin are cut by thirds. So D is now 1 unit away. Here is D now. C, let's count how many units away C is. 1, 2, 3, 4, 5, 6 units from the origin. So 1/3 of 6 is now 2 units from the origin. Remember, our scale factor to scale down is 1/3. So if that was 6 units from the origin, then 1/3 times 6, 1/3 multiplied by 6, that equals 2. Okay? You can do the math. I'll keep going. How many units away is B? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9 units away. So 1/3 of 9 is 3. So there's B right there. How about E? 1 unit away, 2, 3, 4, 5, 6 units away. 1/3 of 6 is 2. Okay, if I scale down with a factor of 1/3, then my shape looks like this. Now, how can I get this shape to transform into the other shape? Well, I think I see a line of reflection, maybe? I think I could reflect over this line right here. If I now do a reflection over this line, then it'll fit right on top. What do I call this line, though? I'm not sure what name I should use for that. It doesn't have any points on the line. Maybe I should do a rotation. Then, yes, let's do a rotation first. If I do a rotation, then I can find something with a name. So let's rotate around the center, and let's rotate 30 degrees. Because on this circular grid, I already counted. I counted how many lines there are. You know what? I'll count them again with you to prove it. 1, 2, wait, don't count the lines. I'm sorry. I'm going to give you misinformation. Count these spaces. 1 space, 2 space, 3 spaces, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. There are 24 spaces around this line, 24 grid spaces. Remember that a circle has 360 degrees. So I already calculated that each one of these grid spaces is 15 degrees because 360 divided by 24, sorry for my messy handwriting, 360 divided by 24 is equal to 15 degrees. So that's how I already know. Anyway, I want us to rotate 30 degrees because we're going 2 of these spaces. Rotate 30 degrees around the center point A. And then E prime is going to go right here on top of point E. So this point is going to end up right here. And we'll have something like, let me change my color. How about a nice red? Oh, how about a nice pink? That's going to make me so happy. Okay, so if I rotate 15 degrees, 1, 2, it's going to be something like, I'm not really good at using a circular grid because you have to really imagine it. It's going to be something like there, and then 1, 2. I think I really messed up. No, 1, 2. Yeah. 1, 2. Yeah. 1, 2. Okay. And then this A is going to be 1, 2. Okay, I think I got it. Here, it's going to look like this. There. Something like that. Now, this point here is called point E. Now I can describe the line of reflection over the line containing point E and the origin point A. Okay, you don't need to do that in your notes, but I'm really glad you followed along and you saw what I did. Type in your answer. What is the sequence of transformations that proves that the larger shape is similar to the smaller shape? Remember, dilations do not change the angles, they only change the lengths. So after a dilation, you get similar figures. Okay, let's type it in. First, a dilation with scale factor of 1/3 and center of dilation around point A. Point A was that center point. Next, a rotation 30 degrees clockwise around the center of rotation. Around the center of rotation? Yeah. Point A. Around the center, let me just say center point A, like that. 30 degrees clockwise around the center point A. Okay, great. Finally, a reflection across the line containing points E and A. Okay, there's the answer. I want you to type that in. You followed along and you saw what I did, but please type in your answer so that I can see you followed along and saw what I did. Let's keep going. Last problem. This is problem number 4. Andre said, I found 2 figures that are congruent, so they can't be similar. Diego said, no, they are similar. The scale factor is 1. Okay, now what's your answer? Do you agree with either of them? Use the definition of similarity to explain your answer. Okay, remember, similar figures, they are proportional to each other. They can be scaled up or scaled down. The lengths have proportional side lengths. The angles are the same. So if he found two figures that are congruent, can they also be similar? I don't know, it's up to you. Let me hear your answer and your explanation. Type your answer here. You don't need that in your notes. Okay, remember, when you're finished with this assignment, you need to take a clear picture of your notes from problems 1 and problem 2. I'd like to see those submitted with your work. When you turn this into the Google Classroom, you're going to have your finished GeoGebra page and 1 or 2 pictures of your notes, your handwritten notes. Good job, guys. See ya.